should be any downhill pieces. So I'm going to look for some downhill. I'm going to highlight down and down. Those are the two downhill. The others are uphill. So from 0, not including, to 1. And from 1 to infinity. Remember, I'm describing, it's going downhill in the pink regions. I get that. But what are the x bounds of those? From 0 to 1, not including 0 or 1, and from 1 to infinity. Voila. All right, what do you think? So far, so good? Bring me back anytime, anytime. Flipping the page, turning this thing over. We're on a roll. We're going to make it to the end. Bounded below is my very first. A function f is what we call bounded below if there's some number b that is less than or equal to every number in the range of f. Any such number b is called a lower bound. So I'm going to fill those in and do read that carefully. I'll show you an example because I don't know if you can pick that out just looking at it. Lower bound. And just an example, a graph speaks volumes about this. So if I go up here and say, all right, here's this kind of y equals b line. I bring in my function, and it's going like that. And my graph goes to b, but never below that. We'd say that b is a lower bound. Okay, it's the bottom of that graph. Same thing with the next one. It would be the upper bound. Go back to green here. Upper bound. Oh, I wrote that in the back order. That's for down here. Bounded above. It's an upper bound. Sorry about that. I was writing in the wrong space. That process of just the contour, that's the other side of that particular graph. If I draw something like this, and we come in with a nice little pinkish graph, and I have here some value that it doesn't go above. So like y equals capital B, because that's what they used in this one. That's an upper bound. Some number the graph goes up to, but never goes past. And then likewise, if you have both, which is something, we just say it's bounded. So that's the general term if you have both. And that's unique to this textbook. It's not, I don't know how often that gets used, but bounded, that's what they say, B-O-U-N. If you can interpret what that is, U-N does not look like U-N. Bounded above and below. The key to this is I think it's best to think of bounded below, a lower bound is kind of like a floor to whatever your function you're dealing with. And it's good to think of bounded above as a ceiling of some kind. And to be bounded in general is to have both. And some good old-fashioned functions to roll with this. W of x, 3x squared minus 4. One of those great-looking parabolas. Are you starting to like the Dirty Dozen? Because you just kind of know what it's a parabola. It's down 4. It's a little thinner than usual. Isn't that cool? Right there is -4. I'm asking for boundedness. Total lower bound right there. Lower bound. Or what we'd say is bounded below. They're both okay. And the bound is actually -4. Onward. Next, let's do something a little more entertaining. X, P of x, is x over 1 plus x squared. That one. This graph is awesome. So Gotta check this out on the graphing calculator. So we're gonna take a peek. I'll sketch it here, but go over here. Try it out. One thing you can do, keep your calculators handy. We'll do some things today with them, but you can turn off an old graph just by clicking on the equal sign. And I'm going to do x over that quantity 1 plus x squared. Yes. I think zoom 6 is probably a good, it's a little too far out at first, but you'll see what I mean. Okay, a little tiny, it's like I can't make that out. Great time to zoom in. So I'm just going to hit zoom in, enter right on the center. That's better. And even that, I could probably get some more window into this. I could go out a little further on x. Wouldn't be bad. I might go to -5 and +5 on my x max and min. That's better. And ultimately what I'll use is then if I go back to my screen up here before, it's kind of to exaggerate this a little bit. It seems to head up toward the axis. Nice little blip there and then heads back to the axis. Kind of sucks back in. Takes a little leap, then comes back toward the axis. This particular graph is what we would call bounded because it's got an upper and lower limit. I mean, it doesn't go on forever in either direction, so we just say it's bounded. It's a great time in both cases, I think, to reference range so that we can talk about just in general how we apply range and how it can be helpful. So both of these graphs, I'm going to put in a little r and talk about range. Okay, so we'll go range there and range here. And the first one, so let's go full screen. You'll have to see that calculator in there. That range on the first one, the parabola, starts at -4, includes -4, goes to infinity. Okay, that's nice. Cool. And then there is that next one. That's a different kind of range. We got to know where it maxes out and where it minimizes. Where's the highest, what's the lowest? And technologically, we've got a tool for that. So we're going to do this calculator-wise. So grab that calculator again. Make sure you have this graph in your y equals graph somewhere. X over quantity 1 plus x squared. So get that in there. We're going to find the maximum and using the calculator as a tool to do that. So this ought to be good. So you go in the graph mode. You can find the maximum by doing second trace to get in that calculator mode up above. So second trace. That calculates things in the picture. Min and max, minimum and maximum are right there. That's what we're going for. We're going to shoot for, I'm going to do a minimum first. I'm just going to work from left to right. It's number 3. Second trace while you're at the graph. Enter. It says left bound. What that means is get left of where you think this minimum occurs. Now, what I mean by minimum is I probably ought to explain that. We will in just a minute. I mean, where's the lowest place on the graph? It's actually more specific. It's where you're hitting like a bottom of a valley is what this graph thinks of. So I'm going to go left of the little valley, hit enter. That looks good. I'm going to go right of the little valley. It says right bound. You can exaggerate that as much as you like. And then you hit enter as long as you're right of the bound. And then your guess is just, get close. You don't have to guess. I can show you what the guess means here in a little bit. It says -0.9999967 and -0.5. That's the x, and then -0.5. I can tell you it's at -1, and it's at a height of -0.5 is what it is. So if I go back to my screen, unlock it, I can actually put in here that this is -0.5. So on that graph. And I know the top one's also 0.5, so I'm not going to find that one right now. But we're going to use that min and max option here a little bit later. That means the range of this one is from -0.5 to 0.5, inclusive. It goes there, it touches. That's the highest it gets. And that occurs at -1 and 1, respectively. Cool? First. Some good stuff. So these things, these little peaks and valleys that I just saw in that graph right there, What we have is a special little scenario. We've got these circle those. I'm gonna darken this. This right here, the little valley here, and then the little peak on the other one up here on the top. Those have names, a local minimum and a local maximum. So we're gonna go down and let you refer to those below. So pick pink, let's go pink again. A local maximum. Okay, is a function value f of a function f is a value of f of c that is greater than or equal to all the range of values in some open interval containing c. Okay, and then the other one says, if at f of c is greater than or equal to all the other values of f, then f of c is called the absolute maximum, which I really like that word, by the way. Sometimes it's just called the maximum. But let's just circle absolute maximum. That's what I would like you to put in that space anyway. Absolute minimum. A local minimum, which I'll describe also in more detail. Okay. A local maximum would be, like in our previous graph up here, this little peak. Local max. The little valley that was here, local min. Okay, that's what those are in that previous graph. Coincidentally, in that graph, those are also the absolute max and the absolute min. They can be both. So I'm actually going to put both on this one because it's the highest overall point too. So you can get little in-between points. Local max and min mean little peaks and valleys. Sometimes those peaks and valleys are like the highest absolute and the lowest absolute point throughout. So local and absolute max, and this is a local and absolute min. I'm going to do 2 more graphs to give you an idea of what all this looks like. These are just kind of fun, swirly, twirly graphs, gumdrops and stuff like that. So here goes. Okay, got it. A, B, C, D, E, F. Interested in what's going on at A, B, C, D, E, and F? Turns out we have several local maximums, like a local max. There's a couple of them. We got one at B. Do you see another one? Got a little peak at B, right there. Yeah, E? Or what'd you say? D, yeah. D as in dog. There's a peak up there. Local max and local max, totally. So local max, like that. So is this one, local max. Is there another one in there? So we got B and D. Which one, F? Ah, that's a really good question. So that's actually, so what about F? I mean, it's like up there. It's way up there. That ends up being our absolute max. So that's a really good point. What do you say about this? This is the absolute max. It can be. So my next graph, so here's what you need to think of a local max as. Top of a hill, top of a peak. That's all it is. Local max really means top of some kind of peak. Sometimes a top of a peak is also the tallest overall point. Sometimes it's not. The tallest overall point is called the absolute max. In this case, it's that F location. Okay, so we got the local ones there. Let's do our local mins. Oh yeah, for this one, you mean like if it doesn't come back down again? Yeah, so a local minimum or a local maximum has to complete enough of a turn so you know it's like a peak of a hill or the bottom of a valley. Yeah, good question. So if I do a local minimum, we got them over at, name your local minimums. I'll take them. I bet you got this one. CE? Does that look pretty good? Bottom of a valley? I like it. Local min?